Hi, how's it going? Hello everyone. It is finally here. After my prototype unit got lost in shipping, I went ahead and ordered this MP200 from the Kickstarter program so I could check it out. This will likely be a multi-part review because there is a lot to cover and I want to be thorough. So what exactly do we have here? This is the Yeswelder Firstess MP200. It is Yeswelder's latest welder, which was launched via a Kickstarter campaign. That campaign has long ended, but it is now available for pre-order on their website, but it is almost twice the price that it was on Kickstarter. So let's dig in and see what you get for that money. This is a dual voltage, multi-process machine. It does seem like MIG is the main focus, but it can also stick weld, scratch start TIG weld, and it has a plasma cutter built in as well. I would definitely classify this as a jack of all trades, master of none, but we'll get into the specific features and capabilities in a bit. It comes with most of the stuff you will need to do all of the processes, though there will be a few extra things you'll most likely need. Most notably, it does not come with a regulator for shielding gas, and you'll probably need a quick connect fitting or some other setup to connect this to your air compressor for plasma cutting. It does come with a short piece of hose and some clamps, so depending on what setup you have for an air compressor, you might be able to make something work, but as for me, I did need to get a fitting. The work clamp and the electrode holder are the same cheap parts that come with most Yeswelder machines, and the stick electrode holder is just stamped steel inside. The work clamp is pretty thin and flimsy. They work, but they are pretty much the cheapest stuff available. The cables are the standard copper-clad aluminum wire with easy melt insulation that comes with all Yeswelder machines. No big surprise, I suppose, though it would have been nice if they had at least upgraded to copper cables for this machine. The included gas hose is actually cheaper than what comes with most machines I've looked at. It's thin-walled hose that kinks easily, but as long as it holds up to the pressure, probably not a big deal. But it just doesn't seem very robust, so don't be too surprised if you have to replace it if it gets subjected to very much abuse. The MIG gun is pretty standard fare for cheap machines. It does seem a bit cheap, but it should work. It uses a standard Euro connector though, so it would be pretty easy to swap out if you had problems. It does use the common Tweco style contact tips, which are readily available in lots of places like Home Depot, Lowe's, and Harbor Freight. The included TIG torch is actually a pretty standard torch, and it is a 17 size, so it's quite a bit less bulky and awkward than the torches that come with a lot of machines. It does have a valve on it because this machine does not have a built-in gas solenoid for TIG welding, and it is a fairly low quality kind of low-end torch, but it should work okay, and I like that it is just a standard torch. The plasma torch is pretty cheap and basic. We'll see how it cuts, but just based on the pretty simple torch design, I don't imagine it'll cut as well as higher-end cutters. That is understandable though, and to be expected considering even the cheapest name brand plasma cutters tend to cost a bit more than this machine. I am curious though if it will cut as well as the $200 Cut 50 I tested out. I wouldn't be surprised if the torch consumables don't last all that long due to the very small size and the simple design, but we'll see. And it does come with a bag of extra consumables. It comes with 2 drive rolls, one for solid wire and one extra one for flux core wire. It also comes with some pipe thread tape, a few parts for the TIG torch, and a very cheap water separator for the plasma cutter. It does not include a proper instruction manual. I think I have the operation of the machine all sorted out, but a proper manual is one thing I've seen a lot of early backers asking for, and so far the best Yeswelder has been able to tell them is to look for third-party reviews on YouTube. They have been saying for a while that they are working on a how-to video of their own, but so far I've heard no word of when that will be available or if a digital or print manual will ever be available. Let's take a closer look at the machine itself. Some have reported that the machines arrived damaged. The door on mine is a little bit crooked. and it doesn't sit quite flat on the table. It rocks just a little bit. Those things might not even be shipping damage because the box was okay. Could just be poor fit and finish, but either way, it's nothing too bad on mine. The back of the machine has the power switch, the two input fittings, one for gas for the plasma cutter, one for shielding gas for MIG. There's also two cooling fans that you can see here. They're actually pretty small, but there are two of them. Has, the data tag. It has the mounting point for the little water separator that it comes for plasma cutting. However, one of the little mounting nuts is actually missing on mine. Not a big deal. I'm sure it'll stay on there good enough with one, but one of those was missing. The power cord does have a 6-50P plug on it, so it is a 240 volt rated plug on the welder cord, and it comes with a 120 volt adapter. Some early backers have reported that their machines come with a 120 volt plug on the machine and include a 240 volt adapter, which is the way Yeswelder does it on most of their machines. In an early Kickstarter update, Yeswelder said that they were changing the power cord setup in response to feedback, and apparently that change was made mid-production of the Kickstarter units. Inside, you have the wire drive system and the mount for the wire spool. There is also a jumper bar to set the wire feed as either positive for solid wire or negative for flux core. If you plan to primarily run one or the other, it really shouldn't be a big deal, but if you plan to swap wire types a lot, just be aware you do have to change this link inside to swap the polarity. On the front of the machine, we see the relatively large color display, as well as two control knobs and a single home button. The knobs do wobble quite a bit, and the shafts are plastic, and you can lose them pretty easily. They don't strike me as super robust. You might want to be a little bit gentle with them. Both of the knobs can click as well, and they are digital encoders which can spin continuously in either direction, so it's a little funny that they have pointers on them. They are recessed a little bit, but also they have this little plastic cover that should provide some additional protection for the display and the knobs. But be careful with this clear cover too. This cover only opens just past the point where it won't fall back down, and that is as far as it opens. If you try to open it any further, it will pop free. And the first time I opened it, I pushed it just a little bit too far, and it popped free and actually broke one of the little nubs that holds it on. And that took very little force. I did not open it very hard at all. I just pushed it a tiny bit past that spot as I was opening it, and that little piece broke. It still works okay, and it is pretty cold in the garage, so that might have played a factor, but just be aware that you might want to be a little bit gentle with this cover. When you fire up the welder, you get a little splash screen on the display, and then it shows the current settings. MIG and flux core modes have the most options. You can set the type of shielding gas, you can choose steel or stainless steel, you can choose 2T or 4T modes, you can set the material thickness, the burn back setting, and you can adjust the current memory slot that you're on. Unfortunately, 030 and 035 inch are the only options for wire size. There's no 023 wire size option. Granted, 030 is thin enough for most things, but some people do like to use 023 inch wire for thin material. With no manual mode, it might be tough to tweak the parameters far enough to get 023 inch wire working well, but it might be possible. In MIG and flux core modes, once you choose your wire size and material thickness, the machine automatically chooses wire feed and voltage settings. There's technically no manual mode. The voltage is always tied to whatever you set your amperage and wire feed speed to. However, the machine does at least display a wire feed speed, and it does seem that you are freely able to adjust that up and down as far as you want, regardless of what you set up here. It's just that voltage will always be tied to whatever you have the wire feed set at. However, you can adjust the voltage up and down from wherever the automatic setting has it, and you can adjust it pretty far, but it's not ever truly manual mode. So even though I would appreciate if it had a full manual mode, This machine is not as restrictive as their MIG 205DS is. This welder also has different memory slots that you can switch between, and however you have these settings, they will be remembered when you switch to a different memories position. So now I'm in memory position 2, but I can actually go back to memory position 1, and my settings are back wherever I left them in memory position 1. And you can see they went right back to where they were. It could be a handy feature, though there really aren't that many parameters to deal with, and if the auto synergic settings work well, it probably isn't that big of a deal to save a bunch of different settings. Still, it could be handy. I will have to verify, however, if the settings actually save through power cycles, because that is one thing they made a point to tell me was not working on the prototype units, but said that it would be fixed in the production units. So I'll have to set a few different memory settings here, and then shut the machine off, turn it back on, and then just go through and verify that they did actually save. And I will let you know how that works out. Other than the auto settings and the memory, this is a fairly basic MIG machine. There's no inductance control, there's no option for a spool gun, there's no cold wire feed, and there's a bolted jumper to change polarity. Granted, you don't need fancy features to lay down a good weld, but just be aware that despite the big color display, this is a fairly basic MIG welder at its core. Pressing home brings you to this screen where you can select the process you want, and while on this screen there is a settings menu that you can get into by pressing the left knob in, but the only thing in that settings menu, no matter where you access it from, no matter what process you're in, the only setting options are the ability to change between metric and imperial units, or to reset the machine to factory specs. So I imagine that's just to clear all the memory settings. Oddly, when you're in this screen, there is a back option that looks like it would be for pressing this knob, but it actually doesn't do anything. You have to press the home button to get back out of there. So you pick your setting, and then you hit select. TIG mode has no options or settings. You can adjust the amperage up and down, and that's it. And despite being called lift TIG everywhere, this machine is not lift start. It is scratch start. It may seem like a small difference to some, but there is a difference. The moment you switch this welder to TIG mode, you have the full 78 volt open circuit voltage. I measured it, 78 volt open circuit voltage at the TIG torch. I actually had a strong suspicion this would be a scratch start machine due to the little promotional clip that Yeswelder have on their website that shows someone starting a TIG arc. You can see a small spray of arcs when the tungsten touches the workpiece, and it clearly sticks pretty hard because the person has to rock the torch back and forth to break the tungsten free. Remember what I said earlier about this being a jack of all trades, master of none? Nowhere is the master of none thing more obvious than in TIG mode. The welder doesn't have a gas solenoid for TIG, there's no option for amperage control as you weld, no high frequency start, no possibility for a torch switch or a foot switch or anything like that, and it is scratch start only. Yes, it can run scratch start TIG, but so can virtually every cheap stick welder if you connect a TIG torch with a built-in valve. All I'm saying is that if TIG welding is important to you, just be aware that TIG welding with this machine is literally as basic as TIG welding gets. Stick mode is fairly simple as well. There's no adjustable arc force or hot start or anything like that. There is a selectable 60-10 mode, so it will be interesting to see how this machine does with 60-10. In plasma cutting mode, you can set 2T or 4T modes, but you can also set the pre and post flow for the compressed air. Normally, you will want a bit of post flow to cool the torch and extend consumable life, but it's a bit surprising to see that both pre and post flow are adjustable. Also, they both default to 0, so you will want to at least bump up the post flow to a few seconds to extend the life of your torch consumables. Inside the welder, nothing super exciting, but there are a few interesting things. The first thing that stands out right away is the fact that they just went absolutely crazy with the little ferrite rings. I don't know if they were chasing some kind of EMI issues or if they just really didn't want any EMI issues, but they are just littered all over the place in here around all the harnesses. The other thing, and I kind of did half suspect this would be the case, but it pretty much is the case, that The welding components and plasma cutting components are completely separate. So you have all essentially the welding circuitry up here, and it's almost like they just kind of put a plasma cutter circuit inside this machine completely separate. It's not really integrated, it's just kind of in here. It's not completely true. The power supply stuff is all up here. It's the plasma cutter still uses the same power supply that the welding circuitry does, so it's really not completely separate, but even still, all the welding IGBTs, diodes, all that kind of stuff is all up here, and the plasma cutting circuitry is completely down here. And that is actually the reason for the two fans. This heatsink and these components are all for the plasma cutting, and so this lower fan is just for the plasma cutting components. And then for the welding circuitry, this upper fan cools all of that. So it's not necessarily a problem, but that does mean that all the welding components up here only have a maybe at most 3-inch fan cooling all that stuff. But it does run all the time, so it's probably enough. Other than that, the overall design and build is pretty much the standard fare for these kind of machines. The capacitors are just a 200 volt, at least these main capacitors here. They are just 200 volt, but they are 105C, so as long as the voltage that's actually being fed to them, it isn't going over that 200 volts, they should be okay. However, there is no kind of provision to keep them from moving around. There's no epoxy or anything kind of holding them to the board or to each other. And if you look closely up in here, you can see that the power cord is actually sandwiched between this one capacitor and the screw that holds one of the IGBTs to the heatsink. It's actually sandwiched in there, and the cord is actually pushing that capacitor down a little bit. So hopefully that won't cause a problem over time, but it's not really ideal to see that it's putting that stress on basically just the little electrical pins for that capacitor. And speaking of things being able to get jostled around or potentially have problems from shock or vibration over time, a couple other things here. This little circuit board, this little standoff circuit board here, it is very loose. I mean, there's just a few pins on this board to where it stands off from kind of the main circuit board, and that's it. There's nothing to strengthen that at all. So this is very, very loose, and that can wobble quite a bit. Also, the transformer down here for the plasma cutting circuit, I might try and get a picture of this or maybe just a better video of it here in a second, but there's like epoxy on the bottom of the transformer that kind of holds the transformer, kind of anchors it to the board. It is all broken completely loose. So this transformer actually can just wobble here on the board, just on the windings. So it's essentially just hanging from the windings right now with no other kind of support because that is broken free. So I don't know if that came because of some jostling and shipping, or maybe it just didn't quite have enough, and there wasn't quite enough anchor points there. But either way, that's broken free. And also this board, it only has anchor points from here back. There's nothing from here out. So you can see the whole thing is kind of loose and wobbly. Not a big deal. None of this stuff is like a huge deal. I don't see anything catastrophic in here. Just little things that, just little things maybe make it not quite as robust for, kind of impact and vibration damage over time. Wow. Some noisy birds. There is a dedicated ground for the case here, and it just comes straight in from the power cord and screws onto this little tab that's resistance welded to the case. I suppose that's good enough, but with just the one wire, it is kind of just relying on the screws, just the sheet metal screws into all the different pieces to kind of transfer that ground around. So not the best grounding I've seen for sure, but at least it does have something. All the main output connections are bolted to the boards. So rather than soldered or something like that, they are bolted connections, which is nice. The main output for the plasma cutter is right here, and that is a little bit close to the case. You can see they kind of smeared some silicone or something on there, but they didn't quite get it all. So, the plasma cutter output can be generally pretty high voltage. So, It would be nice if this was set back a little bit further, or, you know, even if it just had a little bit better insulation there, but it's so close to this that even if the case got bent in, it probably wouldn't hit here, so probably not a big deal. But anyway, that's a quick look inside. Now I'm going to get it put back together, and I'm going to actually do some welding with it. This part of the video is going to be a little different than my normal format because we've been getting snow dumped on us the last couple of days. So I cleaned up the garage and put the Jeep back in before that hits. So I'm not out in the garage right now. For this first video, I focused on using the MP200 for solid wire MIG welding with 75-25 shielding gas. Changing the wire spool isn't too bad, but it does require a tool to remove the adapter when switching between 4-inch and 8-inch spools. Also, the woodruff key in the shaft for the drive roller is slightly loose in the notch, and it fell out of the notch and bounced under the drive mechanism the first time I pulled the roll off to flip it. So be mindful not to lose that when changing or flipping the drive roll. Earlier, I said this welder does not have a cold wire feed option. While that is technically correct, I found that it does have a fast wire feed that can be used after changing wire, so I wanted to make sure I pointed this feature out. It's not marked or labeled anywhere, but pressing and holding the left control knob activates a fast wire feed. Just be cautious because it isn't a cold wire feed. The wire becomes live with 78 volts when you use this feature, just as if you were pulling the trigger on the MIG gun. The only difference is that it runs at high speed instead of a snail's pace. But the wire will be live while feeding, so be aware of that. As for the memory settings, they do save after power cycling the welder, but it always reverts to memory position 1 when powered up. So if you have specific settings for a project on memory position 3, for example, and you power down the machine even for a second, when you power it back up, it will be back at the memory position 1. And at that point, you just have to remember which memory position you were using and switch back to it. The burn back setting didn't make a noticeable difference in any situation. Maybe it will make a difference with flux core, but when running standard C25 MIG, I tested at a wide range of output settings, and whether burn back was set at 0, 10, or anywhere in between, there was no noticeable difference. So how does it actually weld? Perfectly fine, but there are some things to talk about. First, no matter the settings, no matter the situation, the arc is a bit harsh. This is a small thing, and it doesn't prevent the machine from laying down perfectly good welds, but no matter how much I tweak the settings, it still seemed a little harsh. I ran this welder with 030 and 035-inch wire, and with both sizes, the automatic settings were a bit cold and had too much arc voltage. With 030 wire, it ran smooth at most amperages if I turned the arc voltage down about a half a volt. So with a minus 0.5 volt offset, it allowed me to go up and down through the amperage range and get mostly smooth performance. However, at or near max output, it did run smoother with a minus 1 or minus 1.2 volt offset. With 035-inch wire at higher amperages, minus 0.5 to 1 volt was enough. But at amperages of 130 and under, it ran better if I lowered the voltage 1.5 volts from the auto setting. 035 wire, 1/8-inch steel, and I'm using purely the automatic synergic settings, no changes. It has it set to 16.8 volts, 9.8 feet per second, 100 amps. I have it set for just all the automatic settings for 1/8-inch steel, which is what I have here, 035 wire, C25 gas. Cold and kind of sounds like too much voltage, so I'm going to go down 1 volt. Let's try it again. Still sounds a bit much on the voltage, but not sure. Let's go down another half a volt. Not entirely sure that's helping, but it's still not stubbing. Wow, I don't know. This isn't... I don't think this is going to work. I just went down a little bit more on the voltage. Down to 14.9 volts. that actually was better, but it's just super cold. I'm just going to turn it up a little bit. Now I have it turned up, which it now says it's set for 3/16 inch material. The voltage is still down quite a bit. I have it turned down 1.5 volts, so it's currently set at 14.1 feet per minute, supposedly 130 amps, 16.1 volts. So I've, tweaked the automatic settings, but it always kind of shows up at the top what material thickness it's kind of suggesting this settings are for, and it's saying 3/16. That went in much better. Still, I'm down 1.5 volts from the recommended settings. I'm just going to go ahead and turn it up to where it says it, where it thinks it should be, which is 17.6 volts. And I'll just run again a little bit and just see how it sounds. Really harsh, popping, sputtering, not smooth. So, just like with 030 wire, the automatic voltage settings do run too high on this machine, at least on mine. The actual amperage output was pretty close to the set value through about 160 amps or so, even when running on 120 volts. Speaking of which, the max output when running on 120 volts was around 160 amps, which is pretty impressive. It does pull 40 amps from the wall when maxed out on 120 volts though, so if you're running on a standard 20 amp circuit, you'll have to keep your beads short to prevent tripping a breaker. When running on 240 volts, using 030 wire and the default arc voltage, I only got around 160 amps when maxed out because of how much the arc was stuttering. But when I turned the arc voltage down to get a smooth arc, the amperage on 030 wire went up to around 180 to 190 amps. That isn't quite the 200 claimed, but it's not terribly far off. 035-inch wire also ran smoother when I turned the arc voltage down from the auto setting, but it didn't affect the amperage very much. After tweaking the settings and multiple checks, I measured around 180 amps max with 035 wire. I also measured the wire feed speed at various settings. When set at 48.8 feet per minute, I measured 41.8 feet per minute. When set at 25.5 feet per minute, I measured 22.9, and when set at 10.1, I measured 9.3. In inches per minute, those numbers are approximately 585 versus 502, 306 versus 275, and 121 versus 111. So it's not exact, but it's not outrageously far off. Probably the main takeaway from me is that the maximum wire feed speed seems to be right around 500 inches per minute. But it will only reach that 500 inches per minute when set for 030 wire. When set for 035 wire, the setting maxes out at 28.8 feet per minute, which probably ends up being right around 25 actual. In terms of the setup parameters, the material thickness shown on the display is a bit optimistic. When maxed out, the machine says it is set up for 1/2 inch material thickness, but you can see here that I got almost no penetration even on 3/8 inch steel when maxed out. I did clean the pieces and remove the mill scale. They were clean, shiny metal on the entire weld area, even the edge of the vertical piece. I tried again on a slightly smaller set of pieces after a bunch of testing and measurement to get the voltage tweaked to provide the maximum possible output. I also ran these two beads one right after the other, rather than letting the piece cool in between the welds like I did the first time. I also traveled a little faster and tried to really keep the arc just ahead of the puddle. And with all that, I did get it to burn in a little on 3/8 inch steel. But I would still say 3/8 is a stretch even when maxed out. The bead size isn't very large, and I wouldn't be confident those results could be replicated in all situations. And the machine is supposedly set for 1/2 inch material when maxed out, not 3/8. In my opinion, this machine is not capable of welding 1/2 inch material with solid wire MIG using 75-25 shielding gas like I was here. In fact, it always seems to run on the cold side if you go by the material thickness shown on the display. It burns in better if you run hotter than what the thickness setting would suggest. On 1/8 inch steel, it ran better if set for 3/16, and on 3/16, it ran better if I set it on the high end of the 1/4 inch setting. Just something to be aware of. On thin metal, I think the automatic settings may be hot enough in some situations, but they still run a little cold. For example, at one point I set the machine to the 14 gauge setting and started tacking up some 1/16 inch pieces. The tacks didn't break easily, they didn't hold even a little. So I had to bump the amperage up from the auto setting to get the tacks to hold. Not a big deal once you get used to it, but just don't rely too much on the thickness settings shown on the machine. Hopefully I don't sound like I'm nitpicking, I just want to cover all the details I find, and overall for MIG with C25 gas, it does okay. Wire feeding seemed consistent, and not having a full manual mode didn't seem too restrictive, at least with C25 gas and solid wire MIG. We'll see how flux core and possibly even dual shield runs later, but for standard MIG, it's fine. The auto settings get you in the ballpark, and it's not difficult to get your voltage offset dialed in. Just know that you will likely have to tweak the voltage and run a bit hotter than the display suggests to get the best results. This is especially important to be aware of if this is your first machine or if you're new to MIG welding and you're not aware that a cold MIG weld can produce a very good looking weld, but one that has almost zero penetration and not a whole lot of ultimate strength. In fact, I kind of wish automatic settings would tend on the hot side by default rather than the cold side, because pretty much anybody will recognize if they're running too hot, burning through and that kind of thing, and will know to turn the machine down. But a new welder that's laying down a cold weld might think that the weld looks great and that everything's running well, but find out that the weld actually isn't very strong. But that's just me and my thoughts on it. Maybe others disagree. This machine does have a slightly harsh arc, a few quirks, and it's ultimately a pretty basic machine once you get past the first impressions of that color display full of fancy graphics. And I couldn't quite get the 200 amps out of it. But once I got the hang of the quirks, it worked just fine, and output on 120 volts is impressive as long as you understand that the max output will trip a 20 amp breaker unless you keep your duty cycle very short. So that's standard MIG welding with this machine with 7525 gas. I still have a lot to cover on this welder, so this is definitely just a part 1. I'll still be testing flux core, TIG, stick, plasma cutting, and I'll be measuring more things like output voltage, power factor, and more. So stay tuned. And if you have anything in particular you'd like to see me try out with this welder, let me know. And as always, thanks for watching. Take care.